So till now we have studied the operating characteristics of different motors. But now we need to understand this study of operating characteristics is incomplete if we don't know how the characteristics are with respect to each other. Okay. So first we will start with the speed versus armature current. So how are the characteristics going to be like? Here we will plot N and this is armature current IA. For shunt motor at no load, it is going to have a finite value, and as the armature current increases, the speed will fall, right? So let us take this point to be the full load of the armature current IFL. Now we have to find out what are the characteristics for a series and a compound motor which is having the same full load current, full load or the rated current. You can write full load or rated current. So what is meant by rated current? It is usually the current at which the motor operates well. That is called as a rated current. Now what about series motor? For a series motor at no load, the speed is going to be very high. So we can draw somewhere like this, and as armature current increases, it will keep decreasing until it meets this graph here. Okay. So because this is the full load current, we are considering all of the motors with the same full load current. And then finally we have the compound motor. So the compound motor will have a specific value, finite value at no load, and then it will keep falling. It is, you can see it is a mix of both the series characteristics and shunt characteristics because it has both the series and the shunt winding. So the characteristics also you are going to get a mix of both of them. You can write here this is shunt motor. This we have drawn cumulative compound motor. So make sure to mention that. It is cumulative motor. And finally the series motor. Now how will the differential compound motor look like? It is going to start somewhere here and it will increase as current increases uncontrollably. Okay. So for the same full load value, this will be the characteristic for differential compound motor. So this is the speed versus armature current characteristics. Next, torque versus armature current, T versus IA. So how are these characteristics going to look like? We will mark T here, IA here. Now shunt characteristics, we know it is linear relationship, torque is directly proportional to IA. So it will be like this. You can write here this is the shunt motor. Next, what about the series motor? The series motor is torque is proportional to I square. So it will start like this. Initially it will be smaller than shunt and then it will rise rapidly. Okay. So this is the series motor. And finally the cumulative compound motor. So this is going to be higher than both at any given point of time. Okay. Because it is having both the shunt winding and the series winding. So this is cumulative compound motor. Okay. So you can see that for a particular full load current, the torque is going to be the least for shunt. Remember that the full load current usually it will be of substantial value. It will not be less than 1. So the shunt motor at full load current will give the least amount of torque. And then series motor and then finally the compound motor. And finally the last characteristic, speed versus torque, N versus T. So these characteristics will look somewhat similar to the N versus armature current, speed versus armature current. Okay. So it is the shunt motor, if you take, it is going to have a certain value. This is N and T at 0 torque. And there as torque increases, the speed will keep falling. So this is the shunt motor. Now let's say the full load current is somewhere here. Okay. Now for the same full load current, what will be the characteristics for series and compound motor? For the series motor, the speed will be quite high initially and as torque increases, it will keep increasing. Okay. So this is the series motor. And finally the compound motor, it is going to be in between these two. So it has the combined advantages of both. Like a series motor, it can offer a high starting torque, which becomes important in certain applications. And like a shunt motor, it will not overspeed. Okay. So this green one, you can write it as the shunt motor, and the red characteristic is the cumulative compound motor. And finally, you have the blue characteristic series motor. Now one more thing that I want to mention here is sometimes the characteristics will be plotted for same no load speed. Okay. So that means N versus T if you take. So no load speed for series motor anyways it is very high. So if you take only the shunt and the cumulative compound motor, then the characteristic, how will it look like? For the shunt motor it will look something like this, and for cumulative motor it is going to look like this. Okay. So this is shunt and this is cumulative compound motor. Okay. So this is for what? This first characteristic is for same full load current. What will the characteristics look like? And here it is same no load current. Then how will the characteristics look like? We are not taking the series motor, because for series motor the speed is going to be very high at no load. So you cannot compare them. Okay.